Now let's study what is PN junction diode, how a PN junction diode is formed. So whenever we are combining or whenever we are joining our p-type semiconductor with our n-type semiconductor, the device that is formed is called as a PN junction diode. And the contact surface of your p-type semiconductor with n-type semiconductor is called as PN junction. So here you can see that this contact surface is called as your PN junction and this is your PN junction diode. This is the schematic of your PN junction diode. It is a two-terminal device which is having anode and cathode. The one terminal which is connected with your p-type semiconductor, it is your positive terminal or it is called as anode, whereas the another terminal which is connected with your n-type semiconductor is called as cathode or it is a negative terminal. Again, the next one, that is your symbol of your PN junction diode, in which the vertical line is your negative terminal or cathode, whereas the another terminal is your anode. When we talk about the physical component of when we talk about the physical structure of your PN junction diode, here in the diagram you can see that the gray or the silver ring, that is your negative terminal, and the another terminal is your positive terminal. In the symbol, this arrowhead indicates the direction of your conventional current when we are connecting a PN junction in a forward bias. PN junction is a unipolar device. It allows the current to flow only in one direction. Now, what happens when we are combining two different types of semiconductor together, or it is also called as unbiased PN junction? So here in the diagram, you can see that we are having one side, we are having p-type semiconductor, another side we are having n-type semiconductor. When these two types of semiconductor join together, the holes from the p-side semiconductor will diffuse to the inside of your semiconductor, whereas the electrons in your n-side semiconductor will try to diffuse in the p-side semiconductor. This diffusion process will give rise to the diffusion current across the junction. Also, when an electron diffuses from n-type to p-type, we can see that at the junction only a thin layer of ionized donor is left behind on your n-type material. Whereas when your holes which are diffusing from p-type to n-type, again at the junction, you can see that your ionized acceptor is left behind. Both of this donor and acceptor are immobile, right? So because of this ionized donor and acceptor at the junction, you can see that this yellow portion, which is forming a depletion layer. Because of this, the free electrons and holes cannot easily diffuse from n-type to p-type, right? So this uh, region or this yellow portion at the junction is called as depletion region.